5.6b is all about writing equations of parallel and perpendicular lines. You'll need to use your own paper to take notes today. The first example, we're going to jump right into the examples. Number 1. Write the slope-intercept form of an equation for a line that passes through the point -1, -2 and is parallel to the graph y equals -3x minus 2. So we are writing equations of lines today. We're not comparing the slopes of the lines, but we're just writing an equation of the line. So we know that if we want to write an equation in slope-intercept form, we would need the slope and the y-intercept. The problem is we don't have either of these things. We do have a point. Now when you're given a point, instead of starting with slope-intercept form, you will have to start with point-slope form. And point-slope form, if you can remember, is y2 minus y1 equals m times x2 minus x1. And you will be using this form to begin all of the equations today because you'll be given a point. So you'll have to use point-slope form. So we know we have a point, but we need a point and a slope. We've got a point, which is -1, -2. We need to know what the slope is. Here's where the other equation comes in. We need it to be parallel to this equation, this line. So if it's parallel to this line, what do we know about the slopes of the new line and the slope of the original line? They must be exactly the same. So we know what the slope is. The slope of this line is -3. So the slope of our new line needs to also be -3. So now we just need to plug in the information. So we're basically extracting the slope from the equation that's given to us. And then we plug in the point and the slope into the equation. So remember, the y2 becomes y minus our y value, which is -2, equals the slope, which is -3, times x minus our x value, which is -1. And then we can adjust our signs. All right, so we need to solve for y, but before we can do anything here, we need to distribute here. So we get -3x. Now this is -3 times +1, so this becomes -3. Solve then for y to get it into slope-intercept form, so we subtract 2 from both sides, and we get y equals -3x minus 5. And here's our equation in slope-intercept form using this point and the slope of the original line because they're parallel. Okay, let's try a perpendicular example. Let's slide this up. Example number 2, I'm going to abbreviate it. We want it perpendicular to x plus 4y equals 12, and it goes through -3, -2. So like I said, we will always begin with point-slope form because we have a point. All right, so if you want to, you can go ahead and start working on that equation. y2 minus y1 equals m times x2 minus x1. There's a couple ways to go about this, so I'll do it one way on this one. We'll do it a different way on the next one. So we know it's going to be y minus a -2 equals, we don't have a slope, x minus a -3. So we can make these guys happy. All right, but we need a slope. So some people prefer to find the slope first before they start plugging it into the equation. So we need the slope, and the slope is going to always come from the equation that's given to you. Now you can't find the slope until you get it in slope-intercept form. So we need to move this x over to the other side because we need it in y equals mx plus b form. So we subtract x from both sides and we get 4y equals negative x plus 12. We still don't know the slope because we still need to solve for y. So we divide each piece by 4 and we get y equals, remember this is understood to be a 1. So we write negative 1/4 x plus 12 divided by 4, which is 3. So here is the equation of our line in slope-intercept form. Now we have to be careful here. We want it to be perpendicular to this line. So we're not going to use this slope. If this is our original slope, then our perpendicular slope, remember, is flip it and switch it. So we flip it upside down and it becomes 4/1. It was negative, so it now becomes positive. Now when you go to plug this in, you don't want to use 4/1, just use positive 4. So we solve this equation for y. The slope is negative 1/4. Therefore, the perpendicular slope is 4/1, or 4. And that is the slope that we'll use in this equation here. And then we just finish this up. So we need to distribute the 4 like we have in the past. And we get 4x plus 12. Still need to solve for y, so we subtract 2 from both sides. And we get y equals 4x plus 10. Here's our equation in slope-intercept form. So we always use this point and we extract the slope out of the original equation. It will be the same every single time. Why don't you try this one on your own, number 3. We want it perpendicular to y equals 3/5 x minus 4, and it goes through 6 negative 2. So I want you to try that one, and once you've done that one, I want you to also try number 4, which is going to be perpendicular to 2x plus y equals 5 through 2 negative 2. So press pause here, try these two on your own, and come back and check how you did on these. Alright, I trust that you have tried these on your own. Now let's see how you did. Now this equation is already in slope-intercept form, so we can start by identifying the perpendicular slope, which is going to be flip it and switch it of this slope right here. So not just 5/3, but negative 5/3 will be your perpendicular slope. Now we can plug it into the equation. y2 minus y1 equals m times x2 minus x1. And you should get y minus a negative 2 equals negative 5/3 times x minus 6. And you're thinking, oh, but this slope actually will work really well with this 6, so that won't be a problem. So we get y plus 2 equals, this is easy, negative 5/3 x. Now, negative 5/3 times negative 6 we know will be positive, so at least get that sign there. Now, if I do this over to the side, 5/3 times 6/1. Now we've already taken care of the sign, so I'm going to ignore the signs here. We can do one of two things. We can multiply across the top and get 30, multiply across the bottom and get 3, and 30 divided by 3 is 10. Or the other way you can do it is cross reduce. 3 goes into 6 2 times, and 5 times 2 is still 10. So whichever way you'd like to do that. But it comes out to be a nice 10. Now we need to get the y alone, so we subtract 2 from both sides. Y equals negative 5/3 x plus 8. All right, if you got that completely right, give yourself a check. If you did not get it completely right, I want you to circle the place where you went wrong, or write a note where you went wrong. I did this wrong. And then make sure you correct the problem, so you have the correct work on your notes page here. Okay. How about number 4? If you haven't tried number 4 yet, please try number 4 first. It's actually easier than number 3. So please push pause here and try number 4 if you haven't done it yet. So to check this, again, we need to get y alone here, which it's not alone, so we will have to solve it. When we subtract 2x from both sides, we get y equals negative 2x plus 5. So that's in slope-intercept form. We can identify the slope. The slope of this line is negative 2, but we want the perpendicular slope. So we need to flip it and switch it, which means when we flip it upside down, it becomes 1/2. It was negative, so it now becomes positive 1/2. So this is our new perpendicular slope. Now we can start going into the equation. Y minus negative 2 equals 1/2 times x minus the x value, which is 2. So this double negative becomes positive. We get y plus 2 equals 1/2 x, and half of 2 is 1, so minus 1. That's easy. 1/2 of 2 is 1, so 1/2 of negative 2 would be negative 1. And then finish by solving for y by subtracting 2 from both sides. Y equals 1/2 x minus 3. Again, if you got it right, give yourself a check or a star or a you're awesome, whatever. If you didn't get it right, please make sure you correct it and write me a note what you did wrong. Did you use the wrong slope? Did you miss a sign here? But make a note of what you did wrong so we can talk about that tomorrow. If you have any questions, feel free to rewind and watch any of these again.